And this is M4 question 8. I did something very similar in the lectures, but unfortunately what I did is kind of a geometric hack, and it's some trick that applies to the simple problems like the ones I did in the lectures, but it seems it's difficult to apply it here. So what I will do here is I will solve this question again with a more general method. And well, it's not that general as well, but it can be used to solve these problems with only 2 points. So let me start this. We start exactly the same way as what we did in lectures. Basically, draw the 2 points and draw the line. And the first point is 0, 2, so this is x1, x2, and the point x1 is 0, 2, and it's labeled 0 here. And the other point is 3 minus 3, so x2 vector is here, and it's labeled 1. So what I did in class is I drew a line that's kind of in the middle, and then I found these 2 points on the the x1 and x2 axes, and then I solved the equation of the line based on 2 points. Here, it seems these 2 points are very difficult to find, except for some special numbers, like we can find the points. But here, what we'll use is the fact that it actually passed through the midpoint. So here, this is our midpoint between x1 and x2, and we can compute it to be half of 0 plus 3, 1.5, and half of minus 3 plus 2, so minus 0.5. So we know that the line must pass through this point. We also know that this line is perpendicular to our vector from x1 to x2. So the problem is how to use these together. And the first thing to note is that instead of saying the slope, because we may get W1 is 0, W2 is 0, or something like that, so let's describe the line by the normal vector. So the normal vector here, remember from lecture 1, the perceptron algorithm, the W's are basically a vector that's kind of perpendicular to the line or the plane. So this is our W1, W2. And here, we know that it's the same direction as the vector from x1 to x2, but it's some kind of constant multiple. So we will write that equation down. W1, W2 is some multiple, let's call it lambda, x2 minus x1, so the vector from x1 to x2. And the reason why I have x2 minus x1, not x1 minus x2, is because, remember again, from the LTU perceptron lecture, the vector is always pointing to the points labeled 1. Then we have the inequalities correct. So the inequality here is larger than or equal to 0, and the classification boundary, the classification line, should be pointing to the label 1. So that's why we have this, and let's write it down, lambda x2 minus x1, so it's 3 and minus 5. Okay, so it seems we know the slope and we know a point, we can figure out the line now. So this line is W1 times x1 plus W2 x2 plus b is minus 70 is 0, and this point is on the line, and W, we know the expression, so 3 lambda 1.5 minus plus minus 5 lambda minus 0.5 minus 70 is 0. So now you can probably guess we're going to solve for lambda and then put it into the weight vector. So let's do this. 4.5 lambda plus 2.5 is 70. The number works out great. 7 lambda is 70, and lambda is 10. So now we know that W1, W2 is equal to 10 times 3 minus 5. So it's 30 minus 50. So if you are given 2 points, then you can always try this. And if you are given 3 points, then it might be slightly more complicated, but there won't be questions like that on the exams.